Welcome to ArcGIS Pro SDK for .NET technical session on real-time analysis and visualization using ArcGIS Pro real-time API. My name is Tonu Hop. Joining me here today is Zihan Song. We both are product engineers working in the core ArcGIS Pro development team. So what is real-time? So I can safely assume that all of you have used some kind of flight tracking application on your phone or websites like this one, where you can actually see what's going on in the sky, where the locations of the planes are in the Southern California. So this is real-time data. You can see all of them in one shot, or you can just follow one flight, especially like when your friends or families are coming to visit you or they're going somewhere. You can consume the same data in ArcGIS Pro as well. You can visualize one flight data or all the planes that's around Los Angeles airport. So to consume the real-time data, we introduced a new layer called StreamLayer. Right? You can see the source of a StreamLayer is an ArcGIS stream service. So if I go to the StreamLayer endpoint and subscribe to that stream service, then you can see that all the data is being streamed at a very fast rate from there. So stream service, so the focus of this technical session is real-time API, which we introduced in ArcGIS Pro 2.4. This allows the developer to integrate real-time data with the rest of ArcGIS Pro ecosystem and perform some very simple visualization to very sophisticated and advanced analysis in real time with real-time event. Even though the focus of this session is real-time API in ArcGIS Pro SDK, since the only way you can view real-time data on a map is using StreamLayer, it's very critical that we understand how StreamLayer works in ArcGIS Pro in order to work or make good use of ArcGIS Pro real-time API. So what is a StreamLayer? StreamLayer is all about visualizing and analyzing real-time data, basically live data coming in. As you know, all the layers in ArcGIS has some kind of source. For example, FeatureLayer has a source, and it could be a shapefile, or it could be a feature class from file geodatabase, or it could be a layer of a map or feature service. On the other hand, the raster layer could be pointing to a PNG file or a raster dataset from an enterprise geodatabase. Same way, StreamLayer's source is a stream service. I just point out just moments ago as well. We're not going to go into deep detail with the stream service today. There are other sessions that will talk about stream services in more detail. Even though we released ArcGIS Pro SDK for real-time in 2.4, the StreamLayer support in Pro has been around since 2.2. StreamLayer is fundamentally different from any other layer type. Right? When you work with a map, for example, you are zooming in, zooming out, you're panning around, the traditional layers actually goes back to the data source and pulls the data from that data source and draws it. So it happens every time you interact with the map. With the stream service or StreamLayer, it does not wait for your interaction. It waits for the data to come to itself, and it draws or refresh the map with the new data set. You can think of that one as a texting. So your phone does not keep pinging your friend's phone all the time to find out whether they texted you something. Instead, it simply waits. When someone texts you, it arrives to your phone and it buzzes. Another way to think about that one is like your TV or radio stations. So stream service behaves just like TV and radio station, which broadcast shows or music constantly, and your TV or radio set in your car or in a living room actually plays it back to you. StreamLayer does exactly the same thing. You can think of the traditional layer is just like playing YouTube videos, right? So when you click play, it actually downloads the content from one of the YouTube servers and starts playing it on your device. StreamLayer is basically like a feature layer with some real-time component to this one. So that's why it supports point, polyline, polygon, just like regular feature layer. It allows you to symbolize those features with the different symbology. You can view attributes in a pop-up or attribute windows. You can even use that in a geoprocessing tool to do further analysis. With that, I'll hand it back to Zihan to take you deep dive in that StreamLayer and do some cool demos.
Okay, so thanks to Nu, today I'm going to share with you about StreamLayers in ArcGIS Pro. Generally, there are two types of StreamLayers, spatial StreamLayers and attribute-only StreamLayers. Spatial StreamLayers have features with different locations, data such as buses, flights, or animal movement tracking. For attribute-only StreamLayers, we have the features with static locations but varying attributes. So basically, you will not see any geographic movement or location changing showing up on the map if you have an attribute-only StreamLayer. For example, you can have weather station data or river flow speed data. For both types of the StreamLayer, we have streaming controls in Pro that you can see from this screenshot that you can use them to control streaming. So basically, you can stop streaming, resume and start streaming, and discard all your features of the StreamLayer. Within the first type, spatial StreamLayer, we have two subtypes, non-track StreamLayer and track-enabled StreamLayer. For non-track StreamLayers, they usually include in the instance which are totally independent with each other and they're not related. For example, data like 911 instance data or Waze alerts data. From the screenshot, we could see that streaming controls for non-tracked StreamLayer in Pro only decided the total number of the features within the entire layer, and is comparatively really straightforward and simpler. For the track-enabled StreamLayer here, so all the features are related, and they're with this unique track ID, like buses or flights data. You have this unique flights ID or bus ID that you can keep track with those features. So if you want to publish a track-enabled StreamLayer by using Geo Event Server, you need to have a track ID tag to one of your fields for your Geo Event definition. Streaming controls for track-enabled StreamLayer in Pro are all track-based. So you can see from the screenshots here, for example, you can change the number of features per track to store in memory, or you can change the number of features per track that display on your map. So if you compare the controls of these two types of layers side by side, you could find there's a bunch of difference, and I'll cover this in my later demo. So StreamLayers have good capability like regular feature layer that you can update symbology, add labeling, view them both in 2D and 3D. We could also have the analysis on the StreamLayer. You could view the data in attribute table, and we also support definition expression that you could filter out and only show a portion of the data that you're particularly interested in. You could run some GPU tools, get analysis result, and then use chart to show this analysis result. There will be more analysis on StreamLayer in Nu's demo later. So that's all the brief introduction of some basic StreamLayer types and basic functions. Let me show you some demo in ArcGIS Pro. So there are several ways that you can add a StreamLayer in ArcGIS Pro. You can add a StreamLayer as a portal item here, like what I'm doing right now. I type the keywords LA bus and it will show up here. So this type of icon indicate the type is a stream service. You could also add a StreamLayer from a server connection, or if you have published a stream service like I'm doing right now, I am copy and paste stream service and add it from data from past, the URL stream service and with stream server, and I add it to my map. So this is the Waze alerts data that we collected around Los Angeles area. This is a spatial StreamLayer, but a non-track StreamLayer, because each individual instance are totally independent and not related to each other, so we don't have the concept track here. So another thing that you can confirm that if I open the layer properties and go to source, you can see that we have a grid to show some basic information that Nu just showed earlier. Is track aware? No, so it's a non-tracked and spatial StreamLayer. So let me close that and go to the data tab here. So we have several streaming controls here that you can change the data. So now if I click the discard observation, means that you will clear up all your data that I received so far, and it will start over. And you could also use this stop streaming data. You can pause the streaming so no new data will streaming in, and you can take a closer look of your data. Or you can just start streaming and all your data will start streaming again. So when you start streaming, all your previously saved data before you stop streaming will be cleared out of your memory as well. So you have a fresh restart. So here on the right, we have two purging options. You can purge by the number of features of the total layer, entire features of this total layer, or you can purge by time. So now I have the number of observations is 10,000. That's too large for me, and I will change a smaller number from the dropdown, change to 100, or you can just type anything that you want in the dropdown. And now if I purge by time, I will give a smaller number as 5 seconds here. So all the features that stay on your map, which existing more than 5 seconds, will be purged and removed from your map. So this is a non-track StreamLayer. I'm going to show you totally different data here. So this is a bluefin tuna fish data that scientists have been keep track with them for a while. So open the layer properties. You can see this time it's different. So is track aware? Say yes, because it's a track enabled StreamLayer that scientists need to have this unique fish ID to keep track with them. And it will tell you what's your track ID field, it's an ID, and then it's a spatial StreamLayer. So here, so one of the things you might already notice that is we have totally different visualization on this layer. So you can see that I use different fish icon for the current observation or the latest observation of the fish. And for the previous one, I used the dots, but with same color to show the previous location, which is the last location of the fish which they have been recorded. And we have track class here that we use this grayish color lines to connect each observation. And you can also toggle the visibility by using this toggle button, like, oh, I want to turn off the track lines. So you will only see the features, and for previous one, you can turn them off as well. Especially we have this shortcut here in the ribbon, checkbox here. You can say, I want to bring the previous observation back and bring the track lines back. So same purging options, we can purge the track enabled StreamLayer by number of features or by time. As I mentioned earlier in my slides, so all the purging options for track enabled StreamLayer are based on track. And now you might ask, why here you say maximum observation per track is 50, but I only see 5 features per track? Is that because this number, maximum observation per track here in the ribbon, controls the number that you saved in memory. So that's the real data that you received and you saved. And here on the right, on the symbology pane, we have another number control that will determine the number of previous observations that you really display. So let me change it to a larger number here. So it's 40. So you can see all the previously saved data now go show up on my map. So the vice versa, if I change it to a smaller number here on the ribbon as 5, it will give me only 5 features, because although you want to show 40 from the symbology pane, but now you only receive 5 features per track. So that will be the maximum number you will see on the map as well. So these two controls, the control in the ribbon control the number that you received or saved. The number on symbology pane control number that you really display for your map. So for other capability here, you can label your StreamLayer. So now I click label. You can see I add some unique labels for each unique fish with their track ID. And I use ArcGIS expression to label them differently. And also you could add a definition expression here. So like I click here. So now you can see I'm only interested in a particular fish ID as a preset, as a definition expression to filter out. And I make it activate and I click OK. So it will filter out all my data, only left this fish on my map. So this is a spatial StreamLayer but track enabled. So we also have this capability to have 3D StreamLayer. So here is the building, new office building in Esri. I took out a bunch of structure so we can see the internal of the building clearly. So now on the map, we have a coffee cart. So assume that I'm in office and I really want to know where is the current location of the coffee cart. Well, I get my coffee in a short amount of time, I could use ArcGIS Pro to keep track with this moving coffee cart in our 3D building. So ArcGIS Pro can give you the capability to add a 3D model to a StreamLayer. So similar use case can be if you want to track a package within a distribution center, or you want to keep track with your medical equipment inside a hospital building. So give you a capability to do the tracking in a 3D building model. It's pretty cool here with this coffee cart. So the other thing I mentioned earlier is we can have the capability to do some analysis. So here is a StreamLayer that is non-spatial. So this is an attribute-only StreamLayer. You can see there's no movement or changing of the geographic location. So this is data with the river flow in Texas. The thickness of the river represent is the changing of the velocity. So the thicker of the river means that there's more river flow and the higher velocity here. So here on the ribbon, you can see the purging options are the same, that I set a maximum number of observation per track as 5. Means that on each river segment, there are 5 records. And all these 5 records are recorded based on different times, which means that I can make a line chart to show the change of velocity based on time. So now let me run a geoprocessing tool called select by attributes. Because there are so many things going on my map, I only want to make a line chart about 2 river segments. I have a preset expression here because I only want to select this 2 segment with this 2 specific stream ID here, and I run it. You can see that this 2 got highlighted. And now if I stop streaming here, I will open the attribute table. You can see that the attribute table contains all the features that I received from this river so far, so over 700 records. And for selected one, there'll be 10. Let me sort it here. So you can see, because I only select stream ID equals to these 2, so there'll be 5 records for each of them, 10 records in total. And then I can identify, click on one of the river segments, and will open a pop-up with all the information that I need and can view them become part of my analysis. And I close that. And this is a line chart that I could use that just generated based on data I selected. So you can see that there are 2 lines here represent the 2 stream ID, 1 and 051, the darker red, the other end with 060 with the lighter red. And you can see there is a changing of different velocity based on time on the same day. So this is the capability that you can do analysis from your StreamLayer. So just to assume that after you finish that in ArcGIS Pro, and now you want to share it as a web map. So now I'm just quickly share my StreamLayer, like the my water flow map as a web map. Because although I work in the Pro and I want to share my map to my colleagues or the entire organization. So after I share the web map, let me click Manage Web Map here, and now I open it in the map viewer that you should supposed to see a flow map. So now we have all the symbology and everything just keep the same. You can share it with other people. So here are all my demo is about basic StreamLayer types, basic function analysis, and sharing capability. Okay, so now back to you, Tanu.
Thanks, Zihan. So one thing Zihan showed in her last demo is called non-spatial or attribute-only stream service, right? So as you're clearly seeing on the screen that even though we're talking about non-spatial or attribute-only, but you can still see those geometries on the map. So why are we calling them non-spatial or attribute-only? Let's dig deep into that one. For that one, let me switch to my machine and show you with a different stream service. So here is a stream service. And if you look at that stream service endpoint, you see that it does not have any geometry field. It has 2 additional attributes, but none of them are shape. If I subscribe to that one and listen to its feeds, I can see that it only returns some attributes, no geometries either, right? But now, if I add this service in ArcGIS Pro, you'll see that right away it will show all the features in the points data set, right? I can label them with the water level that's being lively broadcasting to the client side, and I can see that they are getting updated, right? Live, you can see that they're constantly getting updated, right? So where are those geometry coming from? So to find that out, I can open my StreamLayer property page, and I can see there is a service capability option information. So it points to a feature layer, and it comes from the stream service endpoint. So if I go to that stream service JSON definition, you'll see that information right here. It's related features, and it points to a stream feature service. If I navigate to that feature service itself, I can see that yes, it does have the geometry, which is a point, and it has a bunch of attributes, additional static attributes right there. So what happens is when you add a stream service like that, it actually gets those additional attributes, static attributes, for example, the name of the station, the IDs, which place it lives in, some other attributes, as well as the geometry from the feature service itself. And then it will never go back to that feature service unless, of course, you restart that StreamLayer. And then it waits for that live broadcast from that non-spatial or attribute-only stream service. So now you know why we call it non-spatial or attribute stream service. So as you see that, these are the location, the points actually represent stream gauges along rivers. And we are constantly monitoring the water level, and it is broadcasted and being actually displayed live on my client side in ArcGIS Pro map. So now that I have that information, of course, you can see that I can label them as well as I can symbolize them, because I want to symbolize such a way that the higher the water level is, the larger or the bigger the point size is. I will change that color to make it a little blue. Do that one. All right, there you go. Now you can see that one. So if I click on one of the features, you can see that the feature has water level is 344. It changes. Now it's 144. I can wait for another few seconds. And if I click on that same feature, now it says 204 feet high, the water level. All right, as you see that here. In addition to that one, it has some other information about different types of flood level, right? So in our scenario, it's good to know the water level, but water level does not equate to flood in all the stream in the same way. The flood level is different based on what type of stream it is and what's the depth and other information. So we have that additional information with this layer that says what is the water level that will actually trigger us to go into the flood mode, or it's a severe flood mode, right? So in our decision process, in the decision-making process, we'd like to actually symbolize or show those points the different color based on whether they are flooded or not, or flooding approached. To do that, we can actually take advantage of arcade expression, simple arcade expression to do that. Let me copy paste the arcade expression, symbolize it, and then I'll come back and explain what I did there. So right now, if you look at my arcade expression, it's very simple, right? It simply says that, hey, if the water level is beyond that major flood category threshold, return 4. If it is beyond that flood threshold, return 2. And if it is 1, then just return it's beyond action threshold, then return 1. So that's why you will see some of them are drawing with yellow color, which means that it's approaching to that flood level. Green basically means we don't have any flood there, and red basically means we have high severe flood there, right? So we can see that with simple live data and with the help of arcade expression, we can do some very analytical visual analysis right there with a simple effort. But what else we can do with this arcade expression, right? As you know, the arcade expression supports some spatial filtering and or spatial operation. We'll take advantage of that one to solve some classic problem which we call geofencing. Geofencing is all about trying to find out whether some moving objects is inside or very close to another objects in the real world. So in this case, we are tracking two vehicles and we'd like to show them with a different color as they are inside that restrictive zone, as you see drawn in that map with the base color. To do that, I will take advantage of arcade expression again. So select the layer from the symbology pane. I'll set my expression right here. You see that it's not complex expression, it's very simple. I can apply, I will come back to that one in a second. So as I did that, I can change set my histogram right way with a different color ramp. Now if I go back to my expression, you see that the expression, it defines the polygon, that is basically the restricted area, and it checks whether the new features that's coming in, it's within that area or not. If it is within the area, returns 1, otherwise returns 0, which basically means draw them with magenta color or cyan color as it moves out of the restricted area, right? So you can see that lots of things you can do very easily. But if I want to, in my case, I want to actually go beyond that. Not only just I want to show them in a different color, I want to send out some text messages, email, or some kind of notification to relevant folks as someone actually comes inside a restricted polygons. So that's where we'll take advantage of the real-time API that we introduced in Pro 2.4. And we are very, very excited about that one. So now I'll switch to another map that using the same data as you saw before, right? Same vehicle, same restricted area. In order to show the notification, I will actually use an add-in that is I wrote using the .NET API. And as you see that the moment it will get inside it, it will actually shows a alert. You see that on the upper right corner, right? So I am using ArcGIS Pro Toast Notification Toast API to show that information, right? So that's one thing I can do, which is geofencing, and I send the notification to everyone. Okay. Another thing you can do is what you call the geo enrichment, right? So I'm representing the same data that I was getting from my previous stream service, but this time I have a definition query just to show only one vehicle, right? And as it is moving along the street, what I would like to do, I would like to show some coffee shops that are within few hundred meters from that location. So I will just subscribe to that stream. Now you'll see that it is updating my search window with all the coffee shops that are found within few hundred meters from that location. Next thing you can do, you can actually take it to the next level. We have other APIs in our in Pro, such as Viewshed Analysis API. In this case, again, I'm using the same feed, but this time I will subscribe to show which the area that will be viewable by those vehicles, those police vehicles, right? This is for the security. So because of this async nature and the unblocking call of the real-time API that we have, I can use the same data set, represent them in 3 different ways and accomplish 3 different things. In the very far left corner, as my taxi is moving along the street, I'm finding all the coffee shops and show them in my search window. The one in the middle is actually tracking a vehicle, find out whether they are actually within a restricted polygon or not, and show notification. On the far right corner, I'm using some kind of security scenario where I want to find out the areas that will be viewable by those police vehicles as they are traveling down the street. So those are great, right? But GIS also about spatial analysis, right? What good GIS without spatial analysis? Let me show you an example where we can do real-time analysis this time. So in this case, we are actually simulating the Florence hurricane that hit the United States last year. So we are looking at the hurricane path that moved along and showing the cone of uncertainty polygon, right? Which is great that we can see that, but what we want to do is that as they're coming along and hit the mainland, we want to see which county will be affected and how much people will be impacted by that. So let me subscribe to that one using my .NET code, and you see that right away as it approaches, it starts selecting all the polygons, and I can even open my chart and see my chart getting updated live, showing the total population as well as the population of 60 years or older in each county that could potentially be impacted by this hurricane. Okay. Otherwise, without this real-time API, you saw that in the Zihan's demo that you have to stop it and open the chart, right? Otherwise, the chart will be undeterministic to find out which area will be affected or polygon will be used. All right. So now how are we doing this? So to do that one, let me go back to my taxi demo and showing this Bing search. To do that, first let me connect to my server and actually stop streaming for a little while. And you see that I stopped the streaming and nothing is updated on my map as well as on my search window. Let me go back to my code behind and enable my breakpoints. If I come back and subscribe to it, now you can see that this is what's happening behind the scene. All right, I'm getting my layer from my map, and then I am subscribing to that stream. Next, I'm simply waiting for the data to arrive, and you see that nothing is happening. It's an unblocking call. I can still interact with my map and everything, but nothing is working, nothing is showing up, right? That's because there is no stream happening from my simulator. So if I step through my simulator, you see that it got to the next one, and here it is. I got to my feature, and I am using the shape of that feature to do a Bing search, right? And there you go. And my search window is updated. So if I go back to my code behind, disable all my breakpoints, come back to my map and my simulator, run the simulator. Now you can see the map is the simulator or stream service is pushing the new live feed. Map is getting it. The real-time API gets kicked in. It finds all the coffee shop within few hundred meters from that location and updating my stream data, right? So with that, let me get back to my slide. So to help you get started, we actually have two documentation that our SDK team put in with the latest release. So one on the left side talks about conceptual thing about StreamLayer and the real-time API. It gets really, really deep in that whole real-time API thing. The side on the right has some great code snippets that you can use to get started very easily. Real-time API does not have too many classes. But most of the classes are being shown in this table. And as you see, those classes are inherited from one of the existing classes that we already have, you are familiar with, such as FeatureLayer, data store, right? And you see that StreamLayer is inherited from FeatureLayer, real-time data store is inherited from data store. On the other hand, real-time cursor or real-time row did not inherit from cursor or row classes. Instead, they actually have similar functionality or capability with some additional capability for real-time data, right? But as you have, I'm pretty sure most of you actually used FeatureLayer or data store or feature class in your code. So if you are familiar with that one, it will not take much time to get yourself familiar with the real-time API. Let's take a look at it, how we can connect to a stream service. So you can use the StreamLayer or real-time data store class to connect, right? So if you use real-time data store class, then you have to actually make explicit call to start streaming. On the other hand, if you use a StreamLayer class, then the streaming starts automatically. Here's a code snippet. We have the URI. Then I can use layer factory, create layer function to create a stream layer, just like FeatureLayer, right? But if I were to want to connect without a stream layer, I can use real-time data store class and provide real-time connection properties and create and get access to the real-time feed. Okay. So there are some cases you want to find out all the features that's already been collected or accumulated on the client side. So just like FeatureLayer, you can use the StreamLayer search function, or you can use feature class or real-time feature class search function. Right? To get to real-time feature class, you can use StreamLayer get feature class function or real-time data stores open table function. And then once you call search, it returns a real-time row cursor. It's just like regular feature cursor. Like for the feature layer, if you call it, it returns a row cursor. In this case, it returns real-time row cursor. And you loop through all the features within that cursor and perform your task. As I mentioned, the search only returns events that are already stored in the memory, right? But the way I did it in my demo is that I was listening to live feed. In order to listen to the live feed, you actually need to subscribe. So we have subscribe functions available for both StreamLayer class and the real-time feature class. It returns the way we return the search does. It returns the real-time row cursor. And then to listen to the real-time feed in unblocking way, you have to call this wait for row async function. Once you do that, it waits until the new data comes in. Once new data comes in, it's just a regular process. You go through, loop through the row cursor using move next, get the feature, and perform the task. You can pass in a query filter in that subscribe function in order for you to do any kind of client-side filtering. You saw that in my Geo Fencing demo where I'm getting all the features from the stream service, but I only want to perform some task when it is within the restricted polygon. So you can use the query filter or a spatial filter for some kind of client-side filtering. Okay, here is a full code sample. The first line says you have to subscribe. Then you call wait for row async. As I mentioned, it is an unblocking call. Then you just keep waiting until new feature comes in. When new feature comes in, use the real-time cursor, move next to loop through all the features. Now here's the unique thing about real-time data. A couple of things happen here. It could be like data comes in, new data comes in, or as Zihan showed you before, the data could get expired, so it gets deleted from that memory. So you can use the get row source function of the feature, real-time feature, to find out what type it is, whether it is getting deleted or it is the new one that is about to be inserted. And you can perform some task based on that information. In many cases, you need to set definition filter, right? You saw in my taxi demo, or you saw in the demo that Zihan showed earlier. In that case, you can use a StreamLayer set definition filter or real-time feature class set filter where clause to set that kind of filter or definition query. When you do that, the filter actually happens on the server side, not on the client side. So stream service will never actually send that event that does not match the criteria you set. Okay. With that, let's move on to another demo, this time with the console application. In this particular case, what I'd like to do is that I like to have some kind of process that I want to run in the background, right? I don't need any mapping. I don't need any layer to do that, right? I'm going to listen to the real-time feed and do some action based on it. So let me run this, my code to begin with. It's doing it in the sample application. I'm sorry, it's in the console application. As you see, it's about to get connected to a stream service. This is a service that similar to one I used before, but it's a little different though. So in this case, it is only listening to that data, the live feed, and it's reporting the gauge ID and the water level, the current water level. Okay, let me show you how I wrote the code in this case. Okay. Before I do that, there's one thing I would like to do. Oops. I would like to actually set a filter here. I don't want to do any, I am telling the stream service to not return any feature that does not meet this criteria, which is the water level has to be greater than 10 feet. And then in addition to writing the gauge ID and the water level, actually I want to do some spatial query. I want to find which county it falls in and what is the population of that county and the other information, right? So let me enable my breakpoints and run my code again. Before I do that, let me go back to my simulator and pause it for a little while. If I run that, see that this is my URL. Okay, I connect to that StreamLayer. I use my StreamLayer connection properties here. I open a real-time data store. I got the first table from that data store. In a stream service, there is only one. There will be only one layer in it. I'm opening my feature class by calling the open table, as you saw in my slides. Then I'm calling to start streaming. Okay, and then once I do that, I set the filter and I subscribe to my real-time feed. And if I run my code now, you'll see that nothing happens. In my console window, it says, hey, I started, I'm waiting for my new live data. And you saw that I actually had my simulator paused. So if I step through it, now see that the new data comes in, I get access to my real-time cursor. I'm moving through my cursor. Now here it is, I'm getting the type of row, and then what I did here, it goes to my show flood information async function, where I'm getting the shape for that stream gauge. Then I'm opening a county's feature class from my local file database, performing a spatial filter operation to find out which county it belongs to. And once I found that, okay, I'm trying to move. I found my search cursor and I'm about to be loop into show the result. Let me disable my breakpoints. Now if I run it, now you see that right away it shows that information. It shows the gauge ID, water level, it finds which county it falls into, which state it is, total population, and what is the feature states. So things that are drawn in the blue are actually coming from that additional function, which is not part of that stream layer itself. So now if I go back to my simulator and start simulating it, you see that result comes back in and it is listening to the new result comes in and it's showing that information on the screen. And you see that it is not actually showing it in every now and then. There was some like a hiccup. That's because the filtering is happening on the server side. So even though the simulator is actually sending that the water level information to the stream service, but stream service says, oh, this water level is below the 10 feet that the definition query set, and I'm not going to send it to this client. So you see that in this console window, you are not seeing any live feed that is where the water level is 10 or below 10 feet. Right. So you see that our StreamLayer and the real-time API is very, very robust, right? So as I mentioned, it is a brand new API and it opens a new frontier. This is the very first of this kind in ArcGIS platform, and we're very excited about that one. You can do some exploratory analysis or perform very, very sophisticated spatial analysis by calling a geoprocessing tool or calling a Python script if you want to. And of course, you can use any .NET libraries, right? Our notification libraries or third-party libraries to send out an email or send text notification to anyone in such case. As you know, the real-time API is also tied up with our StreamLayer because StreamLayer is being powered by the real-time API. So StreamLayer is all about visualizing and analyzing real-time data in live, right? Data are stored in the memory in this case. There are two types of StreamLayer that Zihan mentioned before. One is non-spatial attribute attribute only, where features don't move, but their attribute gets updated live. In this case, the location of stream gauges, or in the Zihan's demo, you saw that they're also showing the location of stream itself or rivers itself. And then the spatial StreamLayer, where feature moves. Like in this case, you are looking at the movement of bluefish tuna in the Atlantic. There's some concept of data expiration, where there you can set some kind of logic to find out when the data will be expired or removed from the memory. It could be based on the time, or it could be based on the number of features. As you see, there was a track aware. You see the bluefish tunas are track aware, so you can see the latest location as well as the previous locations. Okay. And you can actually symbolize those features differently, whether as you see that the latest location is being drawn with the fish icon, whereas the older locations are being drawn with some small circles. You can assign different multiple symbols, and one of them is a line itself. You can use the line to connect all the previous locations with the latest to show the path that each feature traveled. You saw the example with the 3D, so 3D is also supported for StreamLayer, and you can share your data. Before we go, these are some of the help link that you can use to learn more about StreamLayer and our real-time API. With that, thank you very much for attending our session. Hope to see you soon.